Okay, so in this lesson we're going to be looking at relations and functions and making sure we understand how to tell the difference between the two, because this is a significant piece that we're going to be seeing throughout this year. First off, what we see throughout this particular lesson, we're going to be referring back to this data here. What they've done is they've given us some data as far as some closing price of gold in dollars over a period of time. And if you notice, they set up that information as a table and as a graph. There is a right and a wrong way to set up a graph. The one in the middle here is the correct way, where we have the year along the x-axis and the closing price of gold along the y-axis. But if you do end up switching them, even though, again, that's not the correct way to do it, you can see that the shape of the graph is going to change as well. And they're just comparing again down here. They're just saying that they're comparing the two variables are going to be y and p that we're going to look at in this lesson. Now what you may want to do is pause this video and write down this information and then hit play again so you can make sure you have a clear understanding of what this is all about. But let's look at these terms now. Here we have a relation. A relation is any set of ordered pairs. Remember, an ordered pair is like this. It's just an x and a y. So any set of numbers with an x and a y is a relation. Now, when we look at a relation, when we look at a set of ordered pairs, sometimes there'll be situations where we can give that relation a special status. We can give it this elite status, and we call that a function. What that means is that when something's a function, that's when a set of ordered pairs where each x is paired with exactly one y. Now the way I like to look at it is that there's no repeats in the independent variable. And when we get down here, we're going to look at what an independent variable is. But again, so a relation is kind of a broad term. It can be any set of coordinates. A function takes and looks at each relation and says, can I give it a special status? Can I call it a function? And the only time we can do that is if in the independent variable there are no repeats. Let's make sure we understand what a dependent variable and independent variable is. A dependent variable, if you think about what the word dependent means, it means, well, you obviously depend on something. Like each of you guys listening to this is a dependent of your parents. When they file taxes, you qualify as a dependent, meaning that you depend on them for housing, for food, for clothing, and so on. Same thing's true about a dependent variable. Its value depends on the value of the other variable. Where an independent variable, that's completely independent. It can make its own decisions. You can pick anything you want for x. So the definition of an independent variable is a variable whose value other variables depend on. Let's look at this example over here, where we have the y equals 2x plus 4. With that example, the x would be your independent variable, because I can pick any value I wanted to for x. Like let's say if I wanted to put in a 3 for x. Well, 2 times 3 is 6, plus 4 is 10. So my value for y is 10. And the reason why it's 10 is because I chose to input 3 for x, and I got out as my answer, the output is going to be 10. And again, that value of 10 depended on the number we picked for x. If I instead put 10 in there for x, well, 2 times 10 is 20, plus 4 is 24. So when I input 10 in for x, my value that depends on that is going to end up being 24. Now, even though usually your dependent variable is going to be your y and your independent variable is going to be your x, sometimes your homework assignments will want to switch things up, and instead of saying y equals, they'll say x equals 2y plus 4. And in this case, my y in this situation would be my independent variable because I'd put numbers in there for y, and my x would be my dependent variable because my value for x would depend on the numbers I put in for y. Or sometimes they use different variables completely. Like here I have b equals 2 times a minus 10. In this situation, a would be my independent variable because I picked numbers for a. And my value of b, my output, would depend on those numbers that I picked for a. So b would be my dependent variable. A would be my independent variable. Now let's use that information. Let's look back up here at this data. So sometimes we're asked to figure out, or we need to figure out, what is the dependent variable and what's the independent variable. Now 9 times out of 10, in fact I can't think of any situation where the year would not be the independent variable, because the year is going to happen independently. Unless you believe what the Mayans, or the Mayan calendar and what that might bring, 2013 is going to happen, and 2014 is going to happen. So time is going to continue, so that's independent of anything else. For this particular example, our dependent variable is going to be the closing price of gold, because those values depend on the year that it is. So $35.40 was the closing price of gold back in 1969. $150.80 was the closing price of gold in the year 1975. So again, those values depend on the year. And also remember, we talked about the fact that a function, remember this here, this table is a relation. And we talked earlier about the fact that to get at that special status of being a function, we look at the independent variable. We don't look at the dependent variable to see if it's a function. We look at the independent variable. So when I look down this table, there are no repeats. So as a result, that tells me that this data does represent a function. Now here's why that's important, because if it is a function, we need to write out that it is a function, and there's a certain way that we do that. If you notice, I already highlighted this. This is a really important piece, especially what I've highlighted there, where it says the dependent variable is going to be a function of the independent variable. That's always how we phrase it. We always put the dependent variable first. I know it's kind of contrary to what you might think, but it would be the dependent variable is going to be a function of the independent variable. So the independent variable always comes last. So with that gold example, we would say the closing price of gold is a function of the year. And again, not every relation is going to end up being a function, because sometimes there are repeats with the independent variable. In that case, the relation would not be a function. Let's look at this example. In a right triangle, the sum of the measures of two acute angles is 90 degrees. Suppose x is the degree measure of one acute angle and y is the degree measure of the other. So we can write an algebraic sentence to describe the situation. If our two acute angles add up to be 90 degrees, we could say x plus y would equal 90. Well, if we want to write this as an equation, where we have the y by itself, we could subtract x from both sides. If we do that, we get y equals 90 minus x. So looking at that equation, we want to figure out, well, what's the dependent variable and what's the independent variable. So again, an easy way to figure that out is you say, well, if I were to put a number into this equation, where would be the easiest place to put it? And the easiest place to put it would be there for x. So if I said that x was 30, that would mean that x would be my independent variable. My value for y depends on that number that I put in for x. So that means, whoops, I put this down backwards. So that means that y would end up being my dependent variable, because that value of what I'd end up getting as my answer would be 60, depends on the fact that I put 30 in there for x. This is going to end up being the same type of problem. Again, we're looking at y equals 180 minus 2x, and again, x would end up being the x would end up being the independent variable, y would be the dependent variable. But here's where I want to focus on. In this example, they say the percentage of the adult U.S. population aged 25 and over who had earned a 4-year college degree by the year y is given in this table. They ask us two things here. They say, is y a function of p? And then in B it says, is p a function of y? Let's go back up to that previous page. Remember, we highlighted and we starred this paragraph, because this is where we figure out how we phrase when something's a function or not. And remember, let's piece some things together here. Remember that the independent variable would go second. And remember, to figure out if something's a function, we look at the independent variable. So those two things go together. So let's look back at this example. The way they have this phrased, they have y being the dependent variable, and they have p being the independent variable. And in order to see if it's a function, That's what we look for. We look at the independent variable. So in this case, I would look at my p's, and I look to see if there's any repeats. And sure enough, there are. There's repeats here, there's repeats here, there's repeats there. So my answer would be no. And the way that I could phrase that is I could just keep it simple and say because P has repeats. Let's look at the part B here. Again, what they've done is they've switched these around now to say that is P a function of Y. So now Y is what I want to look for. I want to look to see if there's any repeats in this first row. I don't care about the other row. I just care about looking at the independent variable. And again, when you look down that row, there are no repeats. So my answer would be yes, because Y has no repeats. Okay, that's where it's important. So why don't you guys take a second to look at this example. So why don't you hit pause and then we'll talk about it when you're finished. Okay, in this example you should have seen that is Y a function of P. So again, this is my independent variable. So I'd look at P in this case, and when I look at P, sure enough, there's repeats. So for this part, I would say no, because P has repeats. For the second part, for part B, now Y is my independent variable. So now I'm going to be looking at this column. And when you look at that first column, there are no repeats. So my answer is yes, it is a function because Y does not have any repeats. So again, the key here to this lesson is making sure you understand the difference between a function and a relation. Remember, a relation is any set of ordered pairs. A function takes a relation and gives it that elite status. It says that we're going to give it a special name because there are no repeats with the independent variable. And when we know that something's a function, the way we phrase it is we say that the dependent variable is a function of the independent variable. So the independent variable piece goes last. So hopefully that helps with understanding the difference between relations and functions. And good luck on your assignment.